find it easiest to graph my sine curves and my cosine curves off of the unit circle, off of the quadrants, because we want our maxes, our mins, and our zeros. So the x is the cosine, the y is the sine. And your sine pattern goes 0, 1, 0, -1, back to 0. Your cosine, 1, 0, -1, 0, and back to 1. God bless you.
Bless you.
Okay, and any form of that, work from those numbers. So you tell me if you had any questions. Remember, amplitude is always measured positive value. If it's a negative, it's a reflection. And then the amplitude is still the positive value. This gives me my frequency. This tells me I have two complete sine curves in 2 pi. So therefore, if you even say it in degrees, I have two complete curves in 360. How long does it take to complete one of those? 180. So that pi, right? So 2 pi over b is your formula. So sometimes if you forget it, you can kind of make it make sense in degrees and then get it back to radians. So b is frequency. How many complete curves in one full cycle in 2 pi? Okay. And again, we want to sketch. I don't need exact numbers, but I need some kind of thing. Like they do this. They say this is 2 pi. So obviously this has to be pi. So they cut these into 4 quadrants. So so it starts at the 0, the 1, the 0, the -1, the 0. That's one complete cycle, pi. They'll always give you these things like at the ends. This went up to 4, so therefore that guy's a 3. So there's your amplitude from the resting period of your curve to the crest of your curve. Okay. Everybody's good with that? Okay. I just needed you to pull out your periods, your amplitudes, your frequencies. Everybody's good? Amplitude over here, be careful. Amplitude is always positive. This negative gives you a reflection. So when you start like this with your sine curve, multiply this by -2. And that's how your sine curve is going to go. Go ahead.
For a vertical stretch, you don't have to say like if there's a factor of...
Yeah, you should say vertical stretch by a factor of 2.
So you don't take the reciprocal for vertical stretch?
No, because the vertical stretch is doing just that. It's pulling it up.
Okay, so only
Yes.
the horizontal.
The horizontal has an opposite effect. When you stretch it out like this, you really shrunk your period.
Okay.
Right? Because if your period is 2 pi and you stretched it out like this, you really shrunk your period. So it's kind of like a different look. If you 29? Okay, so they gave us this basic curve here. It went to 2 pi, so this basic curve right here is your cosine curve, right? So you're going to start with the basic cosine curve. Now the only thing that changed, it still had the same cycle here. The only thing that changed is it went up here and here. The 0 stayed the same. The whole cycle stayed the same. So all that changed was from 1 to 2. So that's your amplitude. So your amplitude changed.
Okay. Well, it says like this. Oh, it doesn't ask frequency.
Did it ask frequency?
Not
Did I ask frequency? I don't know what it asked. I don't have the directions on mine. Because I originally gave this to you out of the book. I had to copy it all down. Yours has better directions than mine. Everybody's good with doing this? Good? All right, again. Sometimes it's a little bit hard to see, but find where you make one complete cycle. The black line, the dark line, is your basic curve. So this is a basic cosine curve. Notice you have more of these. So therefore, you're pushing them in here. You have a higher frequency. Just follow with your fingers until you complete 1, and then 2. And you can tell right away where's your period. Your period is at pi, okay? You took half, this is from the book, half the period. You took half the period, so they consider this a shrink. They consider this a horizontal shrink. Your period kind of stretched, so your frequency stretched, but your period shrunk. So it's kind of like an opposite effect.
On number 31, where you say that the phase shift was to the right, can you also say to the left?
Let's see. So you started with the sine curve, and they said 6 units to the right here. You could probably say to the left. Let's see. You went from here to here. Yeah, you could say 6 units to the left. It's hard on a phase shift. On a phase shift, I wouldn't really ask you to do the formula unless I tell you it's a phase shift, because sine and cosine are automatically shifted 90 degrees. So do I know I'm working with the sine curve, or would I say that this is like a cosine curve with a reflection? Unless we give you the original, it's hard to tell.
With that, so that's 680.
If I didn't give you the black curve where you saw it came off of the sine curve, you could tell me it's a cosine curve.
Yeah, that's what I did.
But if I think they wanted you to go off of the sine curve.
Well, so you would just say like pi units to the right.
Pi units to the right. Like here's your 2 pi.
I just want to make sure that you can say pi. Like,
See this guy right here?
yeah.
Take this guy and move it to right here. Here's your shift. Right here. You went to the left, that's fine.
Okay.
But to the left, you're not going pi units, you're going 2 pi units to the left.
Yeah, that's.
2 pi to the left.
That's why I was confused.
You just got to be careful. Well, look at the difference. One is a sine curve, one is a cosine curve.
Mm-hmm.
They're 90 degrees apart, right?
Yeah.
So pi units, I'm going this way.
Oh, okay. What's the graph then?
The graph, they wanted you to go off of a sine curve. So otherwise, what we were just talking about is, if you just looked at this lighter graph, you could say that's a cosine curve, right? It's a reflected cosine curve. So really you have your only transformation off of this one is that you reflected this. But they wanted you to see the difference between this original curve, which is a sine curve. This original curve now went here. So if this is 4 pi, half of this is 2 pi, half of that is pi. So you moved this starting point over here. So they just wanted you to say, I have a phase shift, pi units to the right. That's all they wanted you to say. If I just gave you this curve, and I said, what is the equation of this curve right here? You would say, oh, this is a cosine curve with a reflection. But they didn't ask that. They wanted to know from this original one, what did you do to get over to this light one? So you just took it, walked it over, pi units, and then if you visualize this black one sitting right here on this light one, so it just, instead of starting here, it has to go here, or do the hump part, maybe that's easier. From here to here, it's going over pi, only because this is set up to be 4 pi. See, all they wanted you to say was, where am I shifting this? Not the equation of this line, of this curve. It's very hard when you're just looking at a curve by itself to say, I give you this curve. Here's my cosine curve.
No, I understand. I just thought I was asking for us to put the original graph
No,
and the new one. Like
yeah.
this.
All they wanted was this. What happened to this? It took a sine curve and it just shifted it over. It's difficult to, if they don't show you the original curve, because were you a cosine curve or were you a sine curve? So they have to show you the original one. Again, be careful of these guys. This is 4 pi, so this is 2 pi. So they only completed half of this in 2 pi. Then they took this and they moved it up. So there's your B, there's your half. This is the dark curve. Okay, then took this was an amplitude of 1, so we're still 1. Then they took this and they moved it up from here to here. They moved it up to, look at your resting place, always the easiest one. Find the resting place for the curve. So from here to this resting place, they moved it up to. And there's no transformation in the frequency, because that frequency already was there. The only transformation is the vertical shift.
Why is it half to half the frequency?
It is. So it's 4 pi. So half of this is 2 pi. So you did half your sine curve in 2 pi. You need another 2 pi to complete your curve. So your period is 4 pi instead of 2 pi. So your frequency is only half of your curve in 2 pi. But your only transformation from this curve to this curve is your vertical shift. Is it clear? Maybe not as clear in the book? Like, did I give you the directions from the book? In the directions, did I say? Give me the transformation.
Oh, yeah. Transformation off the coordinate.
Off the coordinate. Yeah. Yeah. Okay, this guy too. If you took your sine curve and you shifted it to the right 90 degrees, there's your cosine curve. They are the same curve. Can you put that in your calculator and see if they come out to be the exact same curve? Yeah, because your cosine curve is 90 degrees off from your sine curve. So technically, if I just took them, when we used to use overheads, I would have a sine curve and then I would cosine curve and I would slide overhead over on the other one and you'd see it better. But right now we just use this. But kind of visualize your sine curve just shifting over 90 degrees. And it makes sense because your quadrants are all at 90 degrees. Look from here to here. Didn't they swap from here to here? They shifted 90 degrees. Okay? I'm sorry? We didn't have 42?
No, it's 43.
Oh, I missed one on you, huh?
Yes.
Ah. Okay, so take a look at these. Our amplitudes are changing here. Only this had amplitude changes on the first two. On the second two, you had period changes. Shifts and periods. So you tell me if you have any questions. And I want to make sure you can do this. You can give me one full cycle. I think I said give me one full cycle. So, and we talked about this yesterday. Your curves are infinite. They keep on going. Right, but we always have to have a place where we start our graph and end our graph. We have our window here. So when we ask for one full cycle, it's technically where are we starting it, where are we ending it, even though the curve is endless. And when we graph within your 2 pi to negative 2 pi, its domain is not negative 2 pi to 2 pi. Its domain is still all real numbers. We're just graphing within that window. This guy took a phase shift. Remember, it's C over B. Technically negative C over B, but if you do this first and say this is going to the right, then just do C over B.
Where did you get 9 pi over 4?
So we're moving here to 2 pi. So you have to say x minus pi over 4, start at 0. X minus pi over 4, go to 2 pi, right? Because don't we go from 0 to 2 pi? So we added this. We're going to start at pi over 4. We added pi over 4. So convert 2 pi to fourths. 8 pi over 4. So one complete cycle, one full cycle, goes from 0 to 9, sorry, goes from pi over 4 to 9 pi over 4.
I didn't convert 2 pi.
What if I said give me 2 complete cycles? How would you find 2 complete cycles? what's one period? What's one complete period here? 2 pi. So if I wanted 2 complete cycles, I'm going to go from 0 to where? 2 pi is 1 complete cycle. 4 pi. So I'd set this equal to 4 pi. And I would add this, set this equal. Makes sense, doesn't it? So it would be some 17 pi. So it would be from pi over 4, 17 pi over 4. So doesn't that give me 16 pi over 4? 4 pi? If I wanted to say what was 8 cycles, I would multiply it by 2 pi. To get to 8 cycles, I would multiply it by 8. So it was 16 pi. Remember your increments. Now, I asked you to graph this, and we didn't ask you to graph this, but if I asked you to graph this, you need to know where your increments are. I need to know how many were my quadrants on this. I didn't change, well, this didn't change the frequency on this one. So the frequency was still 1 curve in 2 pi, even though I shifted it over. So my frequency still goes 1 in 2 pi, so every 90 degrees I hit a cycle change. The only difference is I'm going to start at pi over 4. And I'm going to keep on adding 90 to it. Okay. And this guy had half your cycles. That means half in 2 pi, and logically the other half in the other 2 pi, so 4 pi. My curves always leave a lot to be desired, so it's very hard on the board also to make a curve. Okay, did I give you these?
Let's get the first 2.
Just the first 2? Okay. Oh, you guys love that. Now, as bad as they look, all I wanted was your amplitude, your phase shift, your whatever shifts you had to give me here. So the first guy, the amplitude, remember, is always positive. The amplitude is 8. It is a reflection in the x-axis. That's where the negative comes from. You have a phase shift of pi to the left. So you're going to start at pi, at negative pi, and you're going to go to positive pi. Because your B, this guy over here, is still 1. Make sense? I didn't throw this at you yet. I took these out because I didn't throw these at you yet. We just did a basic phase shift. All I wanted you to do was a basic phase shift. So where's my complete cycle going to go? And think about it logically. If I start my cosine curve, it normally starts here. If I start my cosine curve here, then I'll be done at the pi. It's still going to take me 2 pi. If I'm pi on this side of the 0, I'm pi on that side of the 0. I still need 2 pi. Okay? 53 looks a little strange, but follow your rule. Your period is, here's your frequency. This one didn't have a phase shift. If you wanted to, like I said before, move your vertical shift to the end. This has a reflection. What's your amplitude on this guy? I didn't say my amplitude. 1. Okay? And here's your B. This is your B. Right in here. There's your B. So your period is 2 pi over B. Remember, we work in radians. So 3 is a radian measure. It kind of converts. Pi is 3.14. So 3 is shortly right before 3.14.
So what would be the domain for a cycle?
The domain for a cycle, did we give you one? So you're still 1 cycle here. You have no phase shift here. You're still regular 0 to 2 pi.
Oh, okay.
Yeah. I just moved it. If you do like to look at it in the back, because technically you do the one at the end, you can leave it in the front. Just a lot of kids usually miss the vertical shift if it's in the front after they do the whole mess. Good? Okay, I threw a lot
Light.
of